Welcome to the Minnesota Engineering by Design Middle School Grades 6 through 8 Overview presentation. My name is Mike Sandell, and I am the Minnesota Engineering by Design Consortium Director. Engineering by Design is in 3 levels: Pre-K 6 teams, middle school grades 6 through 8, high school grades 9 through 12. In this presentation, we'll be looking through the 6th through 8th grade middle school curriculum for Engineering by Design. This program uses a learning model that is an adaptation of the biological sciences curriculum study that adds a 6th E, engineering. Engineering, capital N, is a noun that refers to teaching and learning engineering. Engineering by Design teaches the lowercase e engineering, which refers to engineering concepts. While capital E engineering is for limited audiences, those that are working to become engineers, Engineering by Design teaches us lowercase e engineering, the engineering concepts that all students should know. The teaching and learning of these engineering concepts will also prepare students for the capital E engineering programs in the future. The first 5 days allows a teacher to set the focus for the course. The expectations for how the class will run will be established. Students will have the opportunity to participate in a design challenge. They will also establish the format for the engineering design journal and student guide. Students will also gain knowledge of class safety procedures, as well as take the course pretest, and the teacher will be able to establish daily classroom routines for the students to follow during this time. The Engineering by Design middle school program features 3 18-week courses for grades 6 through 8, exploring technology, invention and innovation, and technological systems. There are also 2 extension units from the Engineering for All project, vertical farms for fresh food for cities, water, the world in crisis. Technology exists to solve problems through the use of creative solutions that work best by demonstrating careful selection of resources to generate the best outcomes. Use of resources are a result of detailed and accurate plans based on ideas evolved through the utilization of the engineering design process. Students in exploring technology will identify why humans develop technology to meet individual needs and wants, examine how products are improved and invented based on current needs, utilize creativity to develop technology to meet a need or a want, analyze and explain how science, mathematics, and history ensure that technology is developed with more precision and accuracy in meeting the needs of individuals, recognize how current technologies often result in improvements made over time based on current needs and wants, and develop presentations to demonstrate how technology has been modified to meet the demands of society, industry, and individuals. In this course, students will learn about the invention and innovation. They have opportunities to study history of inventions and innovations, including their impacts on society. They learn about the core concepts of technology and about the various approaches to solving problems, including engineering design and experimentation. Students apply their creativity in the invention and innovation of new products and processes or systems. Finally, students learn about various inventions and innovations impact their lives. Students participate in engineering design activities to understand how criteria, constraints, and processes affect designs. Students are involved in activities and experiences where they learn about brainstorming, visualizing, modeling, constructing, testing, experimenting, and refining designs. Students also develop skills in researching for information, communicating, design information, and reporting results. Technological systems can be as small as 2 components working together, or can contain millions of interacting devices. We often break down the macro systems into less complicated microsystems in order to better understand the entire system. However, technology is becoming more integrated and systems are becoming more dependent upon each other than ever before. Electronic systems are interacting with natural biosystems as humans use more and more monitoring devices for medical reasons. Electrical systems are interacting with mechanical and fluid power systems as manufacturing establishments become increasingly automated. Technological systems give students a general background on the different types of systems with a concentration on the connections between these systems. The Engineering for All project has been funded by the National Science Foundation to create, test, and revise 2 6-week modules for middle school technology education classes on the important social context of food and water. The units are titled Vertical Farms, Fresh Food for Cities, Water, the World in Crisis. The units are built on 4 drivers that underpin the Engineering for All approach. These include promoting the potential of engineering as a social good, revisiting unifying engineering technology themes, using design-based engineering activities as authentic context for teaching and learning science, technology, engineering, and mathematics, using informed design as a core pedagogical methodology. There are 2 ways to access the Engineering by Design curriculum. Engineering by Design uses the BUZZ learning management system. All materials are organized in this system, and teachers can easily choose which of the learning materials students will see. Teachers can add materials, quizzes, and other assessments, and save these to use year to year. These materials can also be imported into most learning management systems through the use of a common cartridge. Access is on a yearly subscription basis. There's a standard or download version available to all MTEEA and ITEEA members, or for a fee of $100 per course. Let's take a look at the BUZZ Learning Management System. When a teacher logs into the BUZZ LMS, they are taken to the teacher landing page, in which the courses that they are assigned to teach are displayed. When a course is selected, teachers are brought to the course landing page. Here, teachers will see the course contents. In the course content page, all resources for the activity are organized in a file format. There are tabs for lesson highlights, standards, objectives, resources, assessment, the 6E lesson plan, lab classroom prep, and supporting files. The 6E lesson highlights are shown on the Lesson Highlights tab. Here we see the 6E lesson highlights for this particular lesson. Each lesson is constructed with the 6 E's of engage, explore, explain, engineer, enrich, and evaluate. Access to the BUZZ LMS is subscription-based and follows a format outlined here. There is a $200 per course per teacher subscription fee for individual courses. Middle schools that desire more than one course or have more than one teacher would want to consider the middle school coursework package that includes access to all courses for up to 4 teachers. This subscription fee is $700 for the first 4 teachers and $200 per teacher after, with a $900 max. Use of the BUZZ LMS would also require some initial training to help prepare teachers for teaching the curriculum. The training fee is $600 per teacher for the first course, $400 per course after the first. Currently, training is done virtually. We are planning a summer academy for the summer of 2021. For additional information, please visit our website, Minnesota Engineering by Design, at the address posted here, or contact Mike Sandell, Minnesota Engineering by Design Consortium Director, at the address shown here. Thank you for watching this 912 overview. Please look for the individual course videos on our YouTube site.